Hello, and welcome to this brief exploration of the Moving Pandas library. Moving Pandas is a library that lets you take coordinates representing an entity's movement and turn it into trajectories. Data like the flight radar data we've seen before, AIS data from ships, GPS data coming off your Garmin watch, or maybe downloaded from Strava. It takes those individual coordinates and turns them into line strings with speeds, and lets you manipulate those new trajectories by identifying stops or splitting them into multiple trajectories. We'll be exploring this library using a simulated dataset from a company called Whitespace outside of DC. They create simulated datasets with analytic scenarios built in, and they have a sample dataset available to play with on their website. It's got simulated cell records, license plate reader data, crime data, tax data, vehicle registration data. And in this scenario, there's some data off of a GPS ankle monitor. So we'll be using that inside of Moving Pandas, as well as the crime reports. The analytic scenario that we're given is that a parolee is suspected of continuing to deal drugs, so we're asked to find out what crimes he might be committing. So if we correlate his movement with some of the crime reports, maybe we can identify that. So the two files that we're going to be working with are the crime laydown shapefile that I've created off of this folder of crime reports. Each crime report has a coordinate and a date and often a time. So I turned those into a shapefile laydown. And then we've also got this ankle monitor data, which we'll just go ahead and read in. It's got coordinates and times associated. So to kick off, we're going to import pandas and moving pandas, as well as silence any warnings, just to keep the output a little bit cleaner. So I'll read in that ankle monitor file. Right, so we've got a date time, which currently is a string, a coordinate, as well as some information about the parolee, but I believe this is the same throughout the whole file. So everything's a string except for our coordinate, so we can go ahead and turn that datetime into a datetime object. So the Moving Pandas library will work with any data set that's got a coordinate, a time, and then some sort of identifier, especially if you're working with multiple entities. Here we've only got one entity, this Jared Combs, but if you were dealing with multiple boats or multiple planes, it would create individual trajectories for each of those based on the unique identifier. All right, so we've got 43,000 rows. The prompt, I believe, indicated that there was a full week of data. And we can double check that. Right, so it goes through the 7th to the 11th of 2016. Okay, so maybe it's worth focusing just on a single day for having this run at a reasonable speed. So we'll just filter out just one day. And if you're not familiar, Pandas lets you compare an actual date-time column to just a string, which is very nice. You don't actually have to create a date-time object. So we'll just start with the first day. All right, so and then right off the bat, we can create a Moving Pandas trajectory. So the format that Moving Pandas likes to have data come in as has the date time as the index, and then a actual coordinate column. So it's sort of expecting a time series of a geodata frame, but it doesn't require that. You can actually tell it what the datetime column is and what the coordinate column is, and it will turn it into the format that it works with. So if we call the trajectory class, pass it our data frame, and actually it's probably worth popping over to the documents for a second. there's sort of two main classes that we'll be dealing with. The first is trajectory, and then the trajectory collection. But it's got a bunch of other capabilities. We're also going to use the splitter and the stop detector, but it's got the ability to smooth the trajectory. So if you've got particularly noisy data, um, it's got an aggregator, which I believe if you look on their GitHub, um, the aggregator kind of takes individual things and aggregates them up into commonalities, which is pretty neat. And it's also got a generalizer, which I think sort of, I believe if you go into here, there's a link to a paper or a site that the main author of this library, Anita Grazer, has put together. She's got some pretty cool stuff on here. Actually, so if we look in the trajectory docs, it gives you a few parameters. If you have your data frame in the correct format, it will just take that. But if you don't, you can give it the column name for the date, the X and Y, the projection, as well as a trajectory ID. All right, so let's go back and go ahead and create our trajectory. So the ID, we can just kind of give it anything. Since there's only a single entity here, we'll just give it the guy's name, Skylar Combs. For the time column, we've got date time. All right, so let's start there. We can also give it a projection. All right, so we've got our trajectory object, and it's got a string representation of its bounds and the line string associated. But if you just do .df, you can see the format that it's put it in internally with the geodata frame with the point and the date time as the index. And they've got some cool plotting stuff built in. You can use HoloViz just natively inside of this. So when you install Moving Pandas, it comes with it. And HoloViz has some really nice functionality for plotting geospatial data that I've used a bunch. And I think the coolest, and I don't know if they have an example, so we might have to put one together, but if you, here we go. If you just do two of them with a plus in between them, it plots them side by side, and you can manipulate them simultaneously if you want to do comparisons. But to use that functionality, it's actually just built in, so you can do the trajectory, HV plot. They've got some examples. You can color it by speed, which is kind of cool. We can thicken the line a bit, and we can add a little legend. And HoloViz isn't the fastest library, and I think the implementation here is even just a little bit slower. So we'll give that a second to run. But while that does that, we can take a look at the stop detector. So this is a independent class that will take a trajectory and then create stop points based on some information. You give it a diameter and a minimum duration for each stop. It will also pass you back those stop segments. So get stop points gives you individual points, and we'll take a look at those. But I think it kind of picks the first point. But we'll get those on a plot to take a look. But segments, if you wanted to distill all those segments down into maybe your own version of the actual stop point, if you want maybe the centroid or something like that, you can access this and do that yourself. All right, so we've got our plot here. And we see from the legend on the side that he sort of maxes out at a little over 3.5 meters per second, which I think is like 8-ish miles an hour. But if we kind of zoom in, some of those faster segments are surrounded by much slower segments, so it's kind of seems like he's probably walking, maybe biking, and those are just GPS inaccuracies or uncertainties. If we zoom into some of these areas, we also see kind of blobs where he might have just been hanging out in one spot. So we can identify all of these stops and turn his individual movements into individual trajectories and put them inside of a trajectory collection. So we can start by identifying those stops. So the stop detector takes a time delta, so we have to import that from datetime. And we can create the trajectory stop detector object. And as an input, all that takes is the trajectory that you want to split. And then to get the stops, you call that detector and give it the thresholds that you're interested in. And just looking back at the docs, the maximum diameter, if you're in 4326, is expected to be in meters. And the minimum duration is going to be your time delta. So in this case, we'll do it in seconds and do it like 10 minutes. So this also takes a second to run. But what it gives back, just popping back over to the documentation, is a geodata frame of those points. Once we get those stop points, we can plot them on a map next to the original trajectory using that HoloViz library. All right, so that finished up. We've got a geodata frame back with a stop ID, the point, and the time, I guess, that they were there. So we can plot this directly using HoloViz. Okay, and there's no projection on this. So let's go ahead and set that, otherwise we'll have some trouble actually plotting it. So from HoloViz, we do have to import its pandas functionality. All right, so to plot just from a geodata frame, once you've imported this, it's just hvplot. You do have to specify geo equals true if you've got anything but a web Mercator projection, which we do not, so we have to do that. Turn on tiles, and you can either just set this to true, or you can specify the tiles that you want in the background. And it's actually got the ability to add a hover over. So if we set hover calls, we set that to all, it'll show them all when you hover over a point. And by just using a plus, I'm going to steal all of this, we can plot the trajectory next to it as well. All right, we'll give that a second. All right, I had to stop and go back and add frame height and frame width to these plots, just because I'm working with a pretty limited space here in the Jupyter Notebook. But we've got some scrolling capabilities. So if we look at our original trajectory and we sort of zoom in, we can see there's a bunch of turn that off. Bunch of stops over here, which are picked up here. We also kind of see that these stops are maybe like the entry point or starting point of when they start identifying this cluster. So if you wanted to maybe get the centroid instead, it would make sense to go back to the documentation and get the stop segments and calculate it yourself. But as a starting point, I think this is pretty good. Okay, so next we want to get the trajectories that are maybe not associated with any sort of stop. So we go back to our documentation and look at the trajectory splitter. There's a bunch of ways that you can split up a trajectory. You can do it by speed. So if you're looking for maybe moving cars on a highway or something, and you want to chop off when they go below a certain speed, and maybe on side roads, you could use the speed splitter. But we want to use the stop splitter. And so just like the calculating the stops themselves, we can give it a max diameter and a minimum duration. So we have to create a stop splitter, which just takes the trajectory. And then we can call the split directly. We don't actually have to save this off into an object. So we'll use the same settings that we used to create the stops themselves. And what this gives you back is a trajectory collection. And the reason that it's a collection is because now each one of these movements in between stops is its own trajectory. And putting them inside of a custom class was the solution for Moving Pandas. If we look back at the documentation again, and their documentation is really good. I would definitely recommend reading through it. And Anita Grazer has a number of videos on YouTube. They're quite long, but they're very thorough, and she uses a number of cool examples if you wanted to see some of the stuff in a little bit more depth. But you're able to look at each trajectory individually or look at the collection as a whole. You can pass it a footprint and identify any trajectories that may be passed through that footprint. So it's got some cool stuff in there. All right, so we'll give this a second to finish, and then I would like to plot it. So I'll put that in here while we wait. Line width, and great timing. Because there's a lot less data here, because there's none of those stops, which take up actually a significant portion of the data, we have these individual movements. And so as we saw above, he had taken a stop in the park, he had stopped up here. It's likely his home or something is down here. It looks like maybe we actually didn't fully catch a stop. So maybe we could tweak some settings based on taking a look at the data in here, but now we've broken it out into just segments where he's moving, which is pretty cool. Right, so let's go back to the original trajectory that we've got, and we're going to read in the crime laydown, and we're going to use a neat feature of a trajectory called get position at, where you pass it a time, and it tells you where along that trajectory they are at that time. And if we didn't have that trajectory, we'd have to get cute and find the nearest time for each crime report. So here we can just ask the trajectory where along that line, and it'll interpolate for us. So the first thing we want to do is read in that crime report laydown. And we've gotten this far without importing GeoPandas at all, which is pretty cool. Let's take a quick look at this. We've got a date time column. We've got the associated crime report. So once we've identified some that might be relevant, we can go back and see what kind of crimes they are, and then the geometry. What we want to do is identify the distance between each of these crime reports and where our suspect, Jared Combs, was at that time. So we could use like the Haversign library or something like that, or use a GeoPy to get the distance. But for code simplicity, I think we'll just reproject both to Web Mercator and use the distance function that's built into GeoPandas. It may not be the most accurate, but I think for what we're doing, it's totally adequate. So the trajectory to CRS function actually requires you to give it the PyProj CRS function or class. So we have to import that. And we'll overwrite the trajectory. And we'll do the same for the crime reports. All right, so this is a string, so we have to push this into a date time. And then because we filtered out our data going into the trajectory, we can do that here as well. All right, so now we've got a geodata frame with date time column and a coordinate in 3857. So we can use that trajectory get position at function, and just using some basic pandas functionality of apply, we can pass it the get position at. And it gives us back a series of points, and we can put that into our data frame, and actually we just might as well call the suspect location. And then we can get the distance that our suspect was from each of these. Just using the apply function built into a data frame. Getting the distance between our geometry column and our suspect location column. And this is going to be in meters. All right, so of the 16 crimes that occurred that day, it looks like he was at least half a kilometer away from all of them, except one. And depending on how each of these crimes was geotagged, whether it was maybe the centroid of the building or maybe the street, 41 meters might actually be pretty close. So this would be one to flag to look at maybe in a little bit more detail. But I'm going to take a quick pause here, go back, stop filtering by a single day, create the trajectory for the whole week, and rerun this. And we'll see if we get any more hits besides this one. All right, that actually didn't take that long. So let's add a new column for his distance. And then filter. Let's make a semi-permissive filter and give it like 200 meters just to get an initial filter down. Okay, so it looks like we've got 2 to look at. That might be a little far away, but we could certainly plot them against where he had been. But this is our most likely candidate, so if we're working with some analysts, that might be something that we can pass off to them as something to look at. So I'll leave you with some final thoughts. This is a great library for prototyping. I haven't yet found a good way to scale it up to big data. It's possible you could embed it inside of a Postgres function or inside of a Spark function. But to start getting answers quickly, or if your data just isn't that massive, you can get pretty impressive results without having to reinvent the wheel. This kind of functionality is pretty hard to generalize, but I think Anita Grazer and her team at Moving Pandas has done a great job anticipating the general needs of its users. I'd like to thank Whitespace for letting me have a download of their sample data and graciously letting me use it for this video. If you found this video interesting, I'd certainly appreciate a like, and if you'd like to see more, consider subscribing. If anything was unclear, feel free to ask any questions in the comments or make suggestions on future content you'd like to see. Thanks.